All right, I think it's time. Does my mic work? Well, it's hard to hear you. Okay. No?
From here it doesn't sound like it, but there it's fine.
Awesome. Okay, good. Let's get started. So thanks everyone for coming after lunch. I hope everyone will stay awake. I always have trouble staying awake after lunch, so I hope this will serve to keep you awake. My name is Pepijn Bruienne. I'm a R&D engineer at Duo Security out of Ann Arbor. We are headquartered there, and today I'm hoping to talk a little bit about the concept of BeyondCorp and what it may mean for us Mac admins out there. I don't intend for everyone here to walk away with 100% understanding of BeyondCorp because it's a pretty big concept, but I'm going to kind of break it down in various pieces to kind of give you an idea of like some common concepts that you probably have applied somewhere else in the past, and kind of get an idea of like how this might work in your environment. Maybe not today, but maybe in 6 months, 12 months, a little more. But this is where some organizations that are especially cloud-based are kind of moving to make their life a little easier. So hopefully we will accomplish that today. You can find me on the Twitters and Slack as Bruienne. So if you want to find me there. If you haven't joined Slack, by the way, I highly recommend it. Who here is not on the MacAdmin Slack? That's pretty good. All right, I'll forgive you. I know, that's right. I should say who here is, and then I won't look at the people who don't raise their hands. So a little bit about me. I put in my time 15 plus years as a Mac admin, pretty much worked at every scale company at this point, small, medium, large, enterprise, higher ed. I went from higher ed back into enterprise, if you want to call that. Even worse, I went to work for a vendor, which is like, having worked with them so much, why would I do that? But that's actually pretty fun. I get to, instead of keeping Macs running, I get to now break them for profit, so that's pretty fun. But the point of that is to protect our customers and contribute what I find back to the community, and hopefully help everyone do a better job at that, because we can always do a little bit of a better job, I'm sure. Free open source software user, contributor, author. I've written some things you may have heard of, AutoNBI, which will probably soon be dead. BSD-Pi, a alternative netboot server implemented in Python, probably will also soon be dead, but I'm sure that our people who are imaging out there, netbooting, useful tool. Glad to have been able to contribute that. Like I said, I'm on Slack, Twitter, GitHub, all under the nick I showed you before. Also a guest host on the, or co-host, I guess, on the Mac Admins podcast. Who here, I'll do it right now, who here listens to the Mac Admins podcast? Wow, that is awesome. Well, in the fall, we'll have more t-shirts, so, buy my DVD. So let's move on here. So I want to give a thank you to the PSU Mac Admins crew. They have put on an awesome conference. I wasn't here last year, unfortunately. Being back here this year, it's really great. All the things they've added. I personally love the arcade out there, so good job. Let's keep that in. The hackathon room, et cetera, et cetera. The attendees are great. I've spoken to so many people, I can't even count anymore. And in general, thank you to the Mac admins community at large. I think we are quite a community for kind of everyone showing up here and putting faces to names from the online communities that we're in. So thank you all for making this possible, for attending. So let's do a little bit of BeyondCorp 101. As I said, we'll try to ease into it. So what are attackers looking for from our organization these days, right? It's data. They want our data. They don't care so much about our user information unless it's as a means to get to our data. So we protect that, generally speaking. How, right? We put walls around everything. We might even give them a name, like a cool name, like Firewall. That sounds awesome. I found it a little unintuitive, like, is it on fire? Like, how do I see that? But okay, all right, we came up with that. It predates computer terms, so we'll go with it. But as we know, a lot of those can be breached. No firewall is perfect, unless, of course, you stack firewalls, right? Like you do 2 or 3. What was, I think, what the perfect combination was. So you may think your data is impervious to data and to attacks, and if it is attacked, it will actively defend itself, right? Once they're through the walls, yeah, not so much. Your data is kind of a sitting duck, or in this case, a sitting head on a, I don't know what that is, 90s sci-fi, sometimes confusing. So the data is the nougaty center of your organization, so to say. So how can we make that, how can we protect that better? How can we make the perimeter, the wall, less of a single means to protect that data and making it less lonely? And that's kind of like how it's been, right? Like, who here has, I do a lot of this, but I like to see this. Who here has ever had to fight with the firewall because it was blocking something you didn't want it to be blocked? Quite a few, right? And then when did it not block something when you wanted to block it? Wow. Right? It seems, well, unless you block everything, then I guess you're perfect. But once an attacker is through that wall, it's done. Game over, right? They're through. And you can add some limitations to that, but once they are inside your network, things get a lot easier to do that. And I've talked about this before in other talks about how your user is sort of your attack point, and once they compromise a user, you can start pivoting. Anyone here who was in our workshop also kind of learned a little bit about how pivoting is a thing. You get one less privileged user's credentials, but then you start kind of looking around like, what else can I do with this? Maybe things weren't as configured as securely or as properly or as minutely as they should have been. And there's always a way to find your way through one way or another. So what makes the firewall, or in general, the perimeter, less effective nowadays? So it used to be we all had our network, it was on-premise, everything happened inside. The intranet was a thing, intranet. We had a wall around it, that's it, we're done. But we're doing much more things these days that open us up to external threats, external factors. So there's BYOD, users bringing their own device. You have to sort of strike a balance between allowing them to work with their own device and not having to pay for that device, which is nice, but you also don't want them to walk in with, a $100 Android tablet that comes preloaded with every, virus and malware imaginable. So you need to strike the balance with the stuff. And then, of course, the cloud, software as a service. You're running things that are not on-premise. Some companies are entirely in the cloud. They have nothing on-premise at all. So firewalls obviously are then the responsibility of the vendor, and you have to kind of rely on them doing what they're supposed to do. And that's tough because you don't have as many controls over that. So some examples of this: crunchy on the outside, shooting on the inside, the nougaty center. The thing that started off sort of the whole BeyondCorp concept was the sort of larger Aurora events. I believe someone at McAfee named this initially. That included Google. This was an attack I'll go into in a second. Target was breached, as we know, of course. This was in 2013 when they lost a whole number, millions and millions of credit card data from customers. I know I was affected by that. To get a new card, they gave us shiny new chips, and hopefully that made it better. But you never know. These large institutions. It's hard to tell whether one breach will make them fix everything, and it will never happen again. And pretty much any insider, if you're an insider who has bad intentions, if you have basically unlimited moving around capability within your infrastructure, that can be a problem. So I say Google Aurora. It was, like I said, it was a larger event that involved others, but Google was the sort of the biggest target in this. This was mid to late 2009. This happened, and what it was a number of Chinese advanced persistent threat groups, basically state-sponsored. We think, we never know for sure, groups that attacked a number of large U.S. companies. Google is one of them. Yahoo was also rumored to have been affected. A couple of others, can't think of them now, but some large, really large targets. And they were going, at the time, 2009, this is 8 years ago, they were going after Google's code repositories. And as we know, now I'm sure here everyone possibly uses some kind of code repository that has possibly some data in it that you would not want to have exposed. Too often, folks will publish something to a public code repository with a private key or some other information, a password, a AWS key that you don't want to get out. So they were after that. And in 2009, there wasn't a whole lot of thought about should we secure our code repositories. There was really not. It was kind of like, well, it's internal, so who can get to that? Well, turned out that if you have a sufficiently motivated attacker, they will go after that. I don't know that they necessarily published exactly everything that was affected, but it was a major breach, and it went on for an extended period of time. And their goal, of course, was to get to the source and modify it. So at the time, Google obviously was shipping some well-known pieces of software. There was Chrome, what have you, their own internal code. And the goal was kind of modify the source and hopefully go undetected and ship either something to some kind of spyware or something to further affect others that install this code. This is sort of relevant in that we have just recently seen similar attacks like this on much smaller scale, but in the Mac community we have seen at least two where both transmission, the BitTorrent software, and Handbrake were affected by something very similar like this, where attackers put up modified versions of the applications on their download servers in order to spread malware. That was, quite good. So that wasn't quite the code repositories, but it's a very similar attack where you get to the software supply chain and basically get your malware in there that folks will then spread out. And it did actually end up, in the case of Handbrake, actually affecting Panic, who had one of the main developers had their Git credentials breached, and the attackers were actually able to grab a good chunk of the Panic software code repos for themselves. And they approached them and said, it's malware time, basically. It's ransom time. Pay us, or we're going to publish it. They said, thank you, but no thank you. We'll take the risk because it's kind of, it's a balance between are they going to release further, affected builds of our software out there. Can we deal with that, or do we pay them and hope that they don't? So it's still going on. This is an early version of that, but it was a big target that they went after. So they definitely set their sights high. So at that point, Google said, no more of this internal, external. We're just going to say that we can't trust any networks because it is too much work trying to keep this, what we call trusted network, and then this big sort of untrusted internet network out there. Let's just say everything is untrusted and start with that concept. Other things, like I said, Target was breached through a compromised HVAC vendor portal. They actually sent out malware to HVAC vendors. A lot of information, turns out, was available through public sources. There were write-ups from Microsoft about how Target had implemented, I believe, SCCM, how they set up their domain controllers. A lot of info was just out there, and attackers had a good amount of data to work with to kind of figure out how they wanted to do this. So they sent out phishing email to HVAC vendors, stole their credentials, were able to log into the HVAC vendor portal, and then used further vulnerabilities in that portal to get on the inside. They had a good deal of time to kind of figure out where everything was. They were able to find a improperly configured domain controller and finally get to the point of sale network, and were able to, as we know, install basically swipeware on pretty much every point of sale system out there in the Target stores, at least in the US, and they stole credit cards by the millions. Were able to exfiltrate all their data. Took quite some time for that to be caught, and it was all about lack of network control, and there was also no multi-factor authentication. So if you had the vendor portal credentials, you were good to go. You were in. So those are some examples. This is a phrase I think you want to keep in mind, that a sufficiently successful attacker looks exactly like an insider. So if you are an attacker who knows what they're doing, you can pretty much make yourself look like you're an insider who belongs where they are and belongs in the resources they're looking at. So that will be what an attacker wants to do. They want to get some insider credentials or some other position where they are on the inside, and then use that position to, you know, without drawing too much attention, move around and get to the again to the nougaty core center. So in short, the perimeter ain't what it used to be. We need something a little, you know, a little better. Reaching beyond. This is great. So we got two typical paths here. How easy is it to implement the BeyondCorp concept that I will speak about in a minute? It's easier if you are sort of cloud first, like if you have most of your infrastructure in the cloud, it becomes easier because a lot of these things, a lot of this depends on some kind of single sign-on. So if you have SAML or OAuth or something like that, it becomes easier. Internal systems are not always set up for that. There are ways to sort of gateway that, to bridge those gaps, but thinking about how much work it is in general, if you're mostly cloud, it's easier. Everyone else is harder, but it's more valuable because once you start doing that, you offer a greater level of protection because cloud, well, there's some rain.
That's a cloud service.
Yeah, that's right. This is true, you're right. Very good. I like it. All right, high note, now get out. It's good though, it's thematic. But the point being, like, if you, for internal services, this is more valuable because cloud first and SaaS will, generally speaking, have more protection already on it. Internally, you might be much further behind. So when you switch over or start implementing some of these concepts, you have more potential for big wins here. So these days, there's plenty of enterprise stuff already outside of the perimeter or kind of like moving back and forth. Let's do another crowdsourcing. Who here uses some kind of cloud service for something in their environment? Pretty much just about everyone, right? Except for Jeremy, of course. No cloud. But it's sort of, it almost becomes impossible to not use that, right? Like I think 1Password was it 1Password? LastPass, who was it? Who just announced, LastPass. Who just announced, or sort of unclear what was going on, but they're going like cloud only, and like it's hard these days to not be somehow based in the cloud. And of course, folks use lots of SaaS apps for personal, and as we know, shadow IT kind of makes it hard to limit the impact that SaaS or cloud has on our environment. If we use none of it, we still need to deal with it because our users may just be using Dropbox or Box or what have you, one of the many cloud services that may be a threat to us. So, as I'm here, I should talk about MFA a little bit, right? Yes, multi-factor authentication. Who here uses multi-factor authentication from any vendor at all? I don't care about it. Nice. Any vendor, okay, good. Just adding multi-factor authentication to this stated problem of the firewall is not enough to protect you. Just using MFA is not necessarily enough either because, as we know, I mean, it's good, it's become a good commodity. GitHub makes it very easy. If you use any of Google services, they make it very easy to use hardware keys, etc. More and more services make it easier to use it. Apple is using, well, I guess some version of it, two-step, two-factor. They're not clear yet, but they'll come around. And it's also a value add on enterprise platforms, so it'll get added at some point when enough people ask for it. But you have some limited insight to who actually is logging in. Like it's someone you send a push or an SMS, they approve it, but that's it. But you don't necessarily have any way of knowing if that was the person or the device that you meant to send it to. And I mention this because I'm sure everyone has heard something about SMS not being great as an MFA as a factor. And we tend to say if you don't have to use it, please don't, because it is entirely too easy to call up the mobile provider and say, listen, I'm Stephen Smith, famous quarterback, I believe. I'm not about football. Anyway, I lost my phone. Can you please port it to this phone because reasons? And you don't have to do go through a whole lot of trouble to get that done. get a phone number ported to a phone that is not yours, a number that isn't yours, but you're interested in the user's second factor, you can get SMS on a random phone and start using someone's MFA without too much hassle, which means I can get your phone number, port it to my phone, log into some portal, and get the SMS sent to the phone that I just ported, your number to, and I'm in. That is why, generally speaking, you want to use something like a hardware key, like YubiKeys, very popular. I hope everyone here got a good sale on one during Prime Day, by the way. They were half off, a great deal. Or something like push second factor, where, when I put my phone away, where your phone is essentially an out-of-band factor that is not, sorry, I had a sidebar. There you go. So to go down the MFA hit parade, all the kids are listening to it. Number one, universal second factor. That is a hardware device like a YubiKey that contains the private key, and it can sign authentication communication between a website and a device and your computer. You register it once for, let's say, GitHub. At that point, they have a part of the signing key. They can sign communications between your computer and the site, encrypt some kind of authentication exchange in there. Only your token can work with that. Any other token cannot. And it's a matter usually of tapping the thing, the exchange is done, and you're good to go. That is the best because you can take it out, you can take it with you, you can plug it into any machine, and you can use it. So most people leave it plugged in into their computer. Generally speaking, you should take it out and put it away, because if someone walks away with your computer, they have your token, unless it has some kind of fingerprint or something on it. But generally speaking, number one, it is not widely used. Like, we see single-digit percentage use, and we would really like to get more people to use it, because right now it is the best way to do it. There's a bit of a cost factor, but in general, $50 or so for a token still beats $50 million for a data breach that you need to clean up, and possibly much worse effects. Using some kind of push MFA, so using Apple's APNS push capabilities to send a push to another device that is not your computer, approve it, is sort of the number two. Number three, SMS phone based, and then as an aside, you can use one-time codes as well. But again, if someone gets a hang of those, a hand on those, they can also use it. But SMS and phone based, where it gives a phone number a ring, and picking up is enough to approve it. As stated before, those are easily bypassed these days. So that is the top three in the MFA hit parade. So we use VPN, right? Who here uses VPN for anything? Lots of people using VPN, right? VPN supposedly bridges the gap between using the perimeter to lock it all down and poke holes and do what you need to do, and work remotely or work on systems when you're not near them physically. But you go through, and then you go right back out to the cloud services that you also need to use. So it's kind of like, where are we keeping everything? Like, there's still vulnerabilities. But it doesn't, again, VPNs don't stop attacks on cloud services. Network access control, 802.1x, where you can limit what devices can actually connect to your network here. I'm actually curious, really curious about this one. Who here uses wired 802.1x? Okay, a few people. Yeah, it's the problem with it is that it is a pain to set up and maintain and keep going. It takes a lot of effort. I think Apple in 10.13 has made it a little easier, I believe, with profiles to actually make it possible to get any Ethernet device enrolled in this. But it's sort of like a shotgun. What?
I'm sorry, it's less the setup than it is the maintenance, considering it's 3 departments
Yeah.
worth of people that want to serve
Right.
that football.
There's a lot of overlapping. It takes a lot of extra work. Bad people plugging in once they get inside the network, but again, doesn't stop attacking any SaaS or cloud services you may have running. So, can we do better? No, let's go home. Yes, we can, actually. That would be super unsatisfying if I walked away. So, the concept, the greater concept in BeyondCorp is the idea of the access proxy. So this is, we all know web proxies that you install to maybe cache some data so that other people, so that data is not as, data use is not as heavy, or let's say a caching server is also a good example of a form of proxy. This access proxy is specific in that it is identity aware, and Google recently released their own version of it called the identity aware proxy. Makes sense. And besides passing people in through like reverse proxies, we all know this, right? You put it on your perimeter network, and you have a bunch of services hosted behind it, and the proxy says, oh, you're looking for mail.org or web.org or what may have you. So the proxy kind of like reverse sends you in the right direction. The idea here is that the proxy also checks who you are, where you're coming from, what device you're checking in from, if that device is up to date. If you basically it's a smart. Oh, I don't want to be smart. It's a terrible identity aware. So it has basically a policy engine that decides thumbs up or down. Good thing we have emojis for that. And it looks, like I said, it looks at the location, device user inventory, and it requires that you are actually known in a certain combination of user and devices. So you basically create sort of a profile for every user based on where they're coming from and what they're logging in with. So generally speaking, this will integrate with some kind of IdP using OpenID, OAuth, SAML, depending on what you're using. And generally speaking, the best practice is to make MFA a requirement. So again, refer back to the MFA hit parade for that. Google, besides routing all web traffic through it, they are also routing SSH to this. And you can kind of see how that would be useful. Because if you need some SSH access, a lot of times folks will either have to use the VPN or maybe a jump host of some kind, which again is, excuse me, in my opinion, kind of like just a backdoor by design. Because if someone gets on a jump host, they can get a whole good idea of how your network layout is on the other side of the bridge. So generally speaking, it'll be some kind of VPN or jump host. And there are, I will be very vague about this. Others are working on additional implementations of this, meaning us. But I'm going to keep this real low on the vendor scale because I hate doing that. So, but SSH and other like remote access tools will soon be an option from certain vendors. It's useful because you don't have to use VPN anymore. You can route all your traffic through one access proxy, and you can apply the same policies to these. Like, I'm sure someone here needs to use like a remote desktop for something, right? Like that's still like a thing that you have to do sometimes, especially in the Windows world. You have to sometimes get to a host. And then lots of logging. Logging is good, right? Logging things is good because it allows us to make better decisions next time. Some event happens, we can learn from our logging. So we will log all the requests and decisions that were made, and we can reflect back on them later and make new policies or tweak our policies. Self-service provisioning from the Google aspect, they want to make it easy to use this. So if you bring up a new service, they don't want to make it super complicated to request and can I get this thing provisioned and can you add it? It needs to be easy to use, otherwise people will find other ways, right? Like nature finds a way, I believe. My Jeff Goldblum is not great, but users find a way to not use what you put in place, right? I think we're all very familiar with that. So make it self-service, make it easy, otherwise people don't use it. And then the sort of the back-end communication between the access proxy itself and the services it is proxying for, use some mutual auth, like mutual TLS, where both sides of the communications are encrypting, because some of the actual messaging is done in HTTP, so you want to make sure that things are encrypted and not discoverable for those who may be listening in. So diagrams. So this is kind of how this all fleshes out. So the idea is that there is no more internal or external network. There's either the public network, which is not at a location. It says Google building. It's sort of how this diagram has been built, and kind of people go with that to give an idea of how Google does this. But this is sort of the reference implementation. So there's outside, public network, Starbucks, and there's the Google building, but you'll see that they don't call this, and I was told to use the mouse pointer, they don't call this privileged network or trusted network. They call this unprivileged network. And they do that because they said there are no more trusted networks. We're not trusting a single network. We're going to focus on trusting the user device and the application that they want access to. So at best, you get unprivileged network. At worst, you get public network. So that is a big change here. So no more trusting anything. And then, as you see, I'll do the pointer here. Internally, use 802.1x. I think they have a pretty good system to do that. That goes back to Radius. But Radius also ties into the access control engine that determines who has access to what. So again, it all pipes back to that access control engine that combines a number of factors to determine whether someone is allowed in. Then if you are good with that and you're a managed device meaning management tools are available on the endpoint. I think we all know in the case of Google that is Monkey or specifically Simian and Puppet that they use. So as soon as their tools are in place and they are satisfied that that's the case, all access then goes through the access proxy. And that's pretty much the same for a managed device coming off the public network. So everyone goes through the access proxy for any kind of access at all. Single sign-on, same thing here. Single sign-on is always enforced, which is backed by the user group database, pipelined again into the access control engine. And we'll talk about these pieces here in a second in more depth. But that is basically the idea here. So there are no loopholes. There are no getting around this. You need to be a managed device, and the fact that you are managed means that the access proxy can determine whether you're managed and if you're managed in a way that meets the bar. If you fall below it because you somehow uninstalled Puppet or you're not up to date or otherwise messed with your management tools, the access proxy is going to say, sorry, try again tomorrow, go see your local IT team to get this cleared up. And I think Google specifically, they've talked about this in the past. They have some very good automated ways to actually make sure endpoints are always up to date by using Plan B and things like that. So, but if you break it to such an extent that can't fix it anymore, go talk to IT before you can do anything. So it is in your best interest to not mess with your machine too much because the access proxy is going to say, sorry, £. Okay, so it's all clear, right? Or should we do a little slow? Right? So let's dive into the different pieces a little bit. So user and group database. I think we can kind of get a concept of this, a directory service of some kind where we keep track of our users. And in the case of Google, that is likely similar to the tools that we know from G Suite, right? We have our users in there. We can do grouping. We can do all sorts of fun stuff. But it's not AD or LDAP, so that's a good thing in my book. I should mention OD as well. But in general, it is some kind of directory service where we keep track of users and groups, or some kind of, like I said, cloud-based IDP. There's several out there that are very capable of doing the same thing. And they need to be able to group the users by organizational, geographical, or some other common aspects that make sense for your org. So you kind of want to group them in such a way that makes sense. And obviously, an API would be rather helpful. Otherwise, it will become pretty painful to get stuff out of it if you are using LDAP, and the only way you can get to it is by a series of small batch scripts that may not be scalable. So you want something that has a decent, RESTful API or something similar like that. Most cloud-based IDPs will offer something like that, and there are also cloud-based IDPs that sort of put an API around something like LDAP as well. But that's, it's pretty flexible if you want to set this up. So you need a device inventory database, right? You need to know what devices you have out there so you can actually determine which devices get in. So this could be part of your directory database, like if you use AD or something like that, you have computer records in there, but it might also be something else. It might be coming out of your endpoint management system, let's say. But however you do it, separate or not, there can be only one, right? Highlander rule, there can only be one, because if you have multiple ones, then we get back to the XKCD comic of now there are 112 competing standards. You want one. It may try to compete with itself, but at least it is one, so not more than one. Then you want to make sure that you're actually managing your devices, your endpoints. You want to make sure they are managed in some way, because otherwise, if you don't have control over what's on them and what's updated, you might as well not start on this crazy journey and just open the firewalls and, fire sale. So your device management tool of choice, I don't have to go through the list of management tools that you want to use, but I'm sure we all use something fantastic. The point being is that you want to have some kind of management on there that allows you to put some of the pieces that are involved here, which I'll touch on in a minute, actually get on the endpoint. Like I said, this may actually act as your device inventory, so you may be using something like DEP and integrating with that. So if you want to make, I don't know, that sounds courageous to make DEP or courage your source of truth. But let's say you do that, it would be handy, because if Apple tells you these are the devices you bought and you go with, well, that's my device inventory, that's a pretty good source. And like I said, usual suspects: JAMF, Airwatch, Filewave, Monkey, or some MDM only product. But again, there you want to make sure that it has some kind of way to at least talk to DEP so that you know what you have. So this will be your whitelist of allowed devices. So point being, if it's not managed, it doesn't get access. And how does it know that? Generally speaking, you need some kind of certificate issuer, PKI system that you maintain, or that's part of, say, AD. If you maintain NDES as part of AD, you have my sympathies. It's a rough one, but it does do the job. Or you may be using something like, I think JAMF offers some kind of, does it? I'm sorry, I actually don't use it. To what extent does JAMF actually offer CA? It kind of does, right? Sort of.
It kind of does for MDM.
Okay.
But you can actually forklift that out and hook up to like an ADC.
Yeah, okay, yeah. So I know that some systems have that sort of the capabilities built in. Thank you, Robert. So why do you need this? Because you're going to use your management tools or some way to get a managed device enrolled in your PKI. You're going to put a device certificate or a client certificate, also called, on the machine. You're going to register it with your PKI. You're going to send a CSR, a certificate signing request, to your PKI system that has identifying information of the host in the CSR. So you can use OIDs, but basically some metadata where you say this is the host name, this is the IP address, let's say, some other identifying factors, the serial number. That becomes part of the cert you get back that you place on the host. But anytime this host checks in through the access proxy is going to say, show me the money. Where is the certificate? Do you have one? I need you to sign our communication with the client certificate, or you cannot even get me to respond to you. Once that is verified, then the rest of the game goes on, and we see where you're coming from, what device this is, because we have now identified it as this specific device. We can check to see if your tools are up to date. So this is very important. Excuse me. Something to think about for the future for macOS. A number of laptops now ship with secure enclave processors, part of the Touch Bar Touch ID system. There is the same secure enclave processor that is in every iOS device as of 5S, I believe, iPhone 5S, is now on the Mac. There's a lot of untapped potential there where you can actually roll these certificates on the device from the secure enclave processor. What does that mean? That means that the private key that is required for this basic process does not leave the computer. It cannot be extracted from the secure enclave processor. By design, this signing key stays on the processor. It actually uses a roundabout way to get it to sign requested signing requests. It never leaves. Short of you desoldering the processor and decapping it with a lot of very nasty acids and machinery, and almost impossible. So that would be really great if that at some point in the future would be a possibility, because you can very, very definitively say this is this device and none other. So that's something to something that Apple might have a little bit of a leg up here, or at least get on the same par with something like Google's Chrome OS, which already has the capability of doing that. And then the access control engine, which is all the policies that are made up of all the data that you're collecting. So the device data, the users and groups, and then you can start putting together policies, sort of in human language of this group of users. Let's say sales in this office in San Jose, that have fully up-to-date devices, and we define that by having the latest macOS version installed, 10.12.5, let's say. Their Chrome is up-to-date, and they have up-to-date something else. If all of those factors are satisfied, all those conditions are satisfied, they can access, let's say, the Salesforce system. And otherwise, we are not letting them in because we cannot guarantee that this device might not pose an issue of some kind of vulnerability to our pretty sensitive sales system, let's say. You can do it with developers. Developers must have fully up-to-date systems. They may only be in these offices before they can get to our code repository, let's say. We can even say they need to use this form of MFA, like we will only allow hardware keys before you can get into the system. So you can start crafting policies that are not possible to do with a firewall, because a firewall has some level of smarts, but ultimately it is about ports and IPs and maybe a little bit of location, but you don't have a lot of other very rich control over that. Which leads us to trust inference. This goes with the access control engine, but the idea is that you create rule sets that say, how do I trust a device? When is it trusted? When is it not? And what data am I going to rely on to determine that? So, like I said, you want to grab good data, so your management system or your logging system that may go with it may be grabbing that data, and it may be determining whether full disk encryption file vault 2 is on or off. Are the management agents working? Is Puppet running, and is it good? Is Monkey installing things? Is there a huge backlog of Monkey updates that have not been applied? I can use all of that and say thumbs up or thumbs down. If any of these is no good, go do that. And I can build something around it and say, hey, before you go in, please take care of this thing, update your software, update your browser, do this, these three simple things to get access. You need to balance that a little bit, I'll say. You don't want to be super draconian and say, a new Chrome came out 2 hours ago, I log in, your Chrome is out of date, sorry. You may want to give that a little bit of a cooling off period, let's say a week or two, but you also don't want to get too loose, because then, again, nature, the user finds a way, and they'll just kind of let it go and then be like, why are you suddenly cutting me off? Well, we gave you a month to do it, but if you skip through it every time, then this might be the first time you are actually affected by it. So this is a balancing act. This is somewhere sort of knowing your users and your environment comes into play to make good decisions there. So what does all of this address? Once you do all of this, right? Easy couple of steps to do, right? Right? Okay. This is a big thing to do, and I'm not saying that you can just kind of roll this out in a week. I will give a couple of links at the end. Google has written a number of papers about this, how they went about this, how they actually did this, how a huge organization like Google got everyone to do this and go with the program, and how they switched over. And they wrote a couple of really great papers about how they planned it, how they implemented it, how they're maintaining it, et cetera. And I definitely recommend you read it. It's way too much information to convey here, but I definitely recommend. They're very readable papers. It's just it goes really into Google's internal structure quite a bit. So what does this address? So reduced insider threat. It is no longer just a matter of as soon as you're on our network, you can pretty much do whatever you want. We're now scoping access not to just the network and go ahead, go nuts. We're now saying, you, known user with known device, and known second factor device are allowed access to these and these and these applications. If you are in development, you probably don't need to be in the sales system. And I know that you will have other ways to do that, but if you can centralize that, you can set the rule once and always have it apply versus having to tell that group, the sales group, all right, now don't let anyone on this list log into the sales system. Salespeople don't let, or dev people, don't let anyone on this list get into that. When you have a central rule engine, there's only one, again, the Highlander rule, there's only one place where these decisions are made. So you are doing less double work and having to go back and retrace your steps. So with scoped user access to apps, resources, an attacker can do much less damage. So even if they get all this stuff compromised, they still only have access to the limited scope of what that particular user has access to. There's much less pivoting capability because you simply do not have the access. Also policy gaps, like I said, if multiple teams are doing their own access, it's very, very possible that one weaker set of rules can be found somewhere that overrides a stronger set of rules, and someone can walk into resources that they shouldn't have access to, but because there are two competing standards, that creates policy gaps. So the concept here of BeyondCorp is this. We address both the internal systems by having an access proxy that bridges our internal systems and our cloud systems in the same way. We have trusted devices. We have either, as we see here, we have a desktop device, we have a mobile device, and users that use them and apply the enforcement the same way to everything. And the central concept of this is really the important part because you're only managing one set of rules. And you go by trusted. You determine what is trusted, what is not, and if it's not trusted, it's not getting in. Again, that is the untrusted network concept. Why is this awesome? Because by implementing BeyondCorp, you might possibly be able to set your VPN on fire, right? Like physically, like pour gasoline on it and put it on fire is what I mean. I don't mean, but by usage, I mean they're pretty expensive, right? So maybe not setting on fire. I'd return it to the vendor. So that being said, basically, you might very well be able to move away from using VPN entirely and getting rid of the pains and hassles that that comes with that. Because in a BeyondCorp world, attackers have a lot more work to do. They don't just have to get through your VPN and start looking around, ringing doorbells and checking door handles. You have to compromise username, password, second factor, the endpoint laptop in this case, and a phone or hardware token to get just access to whatever by policy that user has access to, which is much harder to do if you keep all your devices patched by way of rule sets and by way of enforcement. So getting to that system may not be as easy as well because it is fully patched, and thus things like, I don't know, root pipe or something simply cannot do any damage because you are keeping up to date. Obviously, it's always a race, right, between where the Apple, the vendor, is with security and where the next attack will come from. But generally speaking, number one, I should have put that in here. I've shown this in other talks. But basically, differences between what sort of normal, regular users think are the 5 most important things to do for security, and what professionals think is important. And users, it's change my password often, don't go to sketchy websites, which is fairly subjective, things like that. But really, the 5 things that you need to do: patch often and early, use second factor. What else was it? Use a password manager. Use unique, strong passwords. That's 5. Sorry, I counted 1. So 5. So really, that's it. Your security hygiene is much more important than determining whether the website you're going to is sketchy, because it might not be that but someone may be running a flash ad banner that is sketchy that just takes over your screen and tells you to call 1888 save my Mac. So that is very important. Same goes here. Follow best, security hygiene best practices becomes much harder, especially if you have an ability to enforce it. So Authenticate the user with more than a password. Check, like I said, checking the hygiene of the device. Is it up to date? Is everything up to date? Third-party applications, are they up to date? Are there applications installed that you don't ever want to see? So if someone has Box installed and you don't like the cut of their jib, let's say, you can say, no Box allowed. Go remove that and we'll talk. Marking device as trusted and making sure they're together. So make sure that when I want to log in from my laptop, you get a response from my main cell phone. And don't trust SMS, let's say. So really, in a BeyondCorp world, it doesn't matter where the app is. They get the same checks regardless. And the perimeter is not going away. I'm not foolish to think that this will just replace everyone's firewalls and other methods they're using right now in a heartbeat. But the concept is definitely something that is on the rise. And I think it would be beneficial to everyone to look in this a little further and see what you can do with some of these concepts to protect your systems a little better. And it just won't be the only protection that's out there anymore. And that's it. I blew through this. Pretty good, 24 minutes. So I take questions. I have down here, this thing here. Whoa, what the heck? Oh, sweet. Oh, there we go.
Wow.
This is a QR code. You may have seen those. It's just a link bundle of all the Google papers that have been written about it, so you can go there. We wrote a couple of non-vendory conceptual things, so I felt okay about including these. This just talks a little more about BeyondCorp, creating access policies. How would you actually do that? This is the feedback URL I was asked to include. So with that, I will gladly take some questions, and let's talk. Yes. Oh, wait, I guess. I went to the speaker thing and everything, and I still forgot. There you go.
Something I was curious about is pretty new to all of this, but trying to figure out like what are options for each of those components. Like the managed part, managed devices, that's pretty obvious, most NPM solutions, but I have no idea what an access control engine I would look at starting using that could talk to all of this, or a certificate manager that would integrate itself with all of this. So having like simple examples of one or two for each of those components would help me a lot.
Yeah, so I think what you definitely want to do, the first thing you want to look at is just at what Google has put up in the way of the identity-aware proxy, because it's more than just the proxy. They give some really good examples of how you can string that together. I want to say Netflix has recently released some open source tooling that kind of does the same thing, where it takes rules, logging, and creates rule sets about. It's actually a pretty nice system where they have sort of a dashboard, and you can go to any user and see like anomalous login events, where you can see, hey, this is kind of weird. Like suddenly the CFO logged in from an IP somewhere in Russia, and they're in their office. Like, what's going on? Like, so it will flag that, and they have a very nice system. I forget the exact names of the tools, but if you look up Netflix on GitHub, I'm pretty sure you'll find it right away. It was released a couple of months ago, and it's a really powerful system. So I think that would be a great first step to kind of look at how they throw things together, how they get logging and fold it back into policy decision making. Any other questions?
So I assume with the proxy service that even if you're accessing a cloud-based service through that let's say Salesforce, for instance, you would want to restrict access to Salesforce only through that proxy access service.
Right.
Have you seen cloud providers trying to implement some of these limitations or features to restrict that?
Well, generally speaking, they will offer like SSO capabilities, and then leave it up to the implementer to tie something to it. I mean, I don't know that there's single SaaS providers that kind of implement that. They because that's a pretty big thing to get into for them, and it's a lot of like overhead. So they provide sort of the SSO capabilities that then allow you to sort of group the other things around it. So I would definitely say, if you're considering this, the first thing you want to do is take an inventory of systems that you might want to protect. Do they all support SSO, first of all? Or do you need to go through some hoops to make that happen? Or do they just not support it? And then it may be time to start looking for something that does, because ultimately, if something doesn't support SSO, it's not really future-proof, I would say, probably. Other questions? Nope. All right, well. I put that in. I said questions, not comments, but for you, I'll make an exception. Throw him the. Anyone who wants to leave can start leaving. Okay.
Absolutely. The two things that I had while I'm actively getting paged somewhere else is that one, thinking about the SEP reminds me of the YubiKey stuck in the port that you want to touch to just let it know that a human is
Right.
on the other end of the computer. I still don't see. I guess I do have a question.
Yeah, there you go. You can do it.
Let me make another statement first, though. Just, I'm sorry.
I'll have some coffee. Go ahead.
There's
We got 20.
there was someone presenting in here that we both attended. I think that he was talking about how he has PKI that he uses Puppet, essentially their CA for free, and instead of them getting Duo or some other way to do a push as a second factor, they check for the presence of the cert while VPNing.
Yeah, that's bad.
It's something that you know, your password, and it's something that the computer has.
Yeah, and that's something that I can take off your computer and take somewhere else. Yeah, don't use, currently in the current situation, don't use certificates as a trusted second factor. I know there are some vendors out there that say password, certificate, 2 factors, we're done. It is not, because I can get your certificates out of your keychain in 5 seconds. So,
But
not
how is that different than the YubiKey being taken by someone as well?
I cannot physically get the private key out of a YubiKey. I can dump your entire keychain with a keychain cracker, like I say, in about 15 seconds, and take all your private keys out and take them somewhere else to another machine. If my purpose is to take that info, put it on a computer, and do as I want. I cannot get it off the YubiKey, like I said, unless I.
So it's the presence in multiple places at the same time, essentially.
Not multiple. It's that the fact that I cannot take the physical private key off the device.
If I physically take the YubiKey.
Well, right, but you will want to have some, either like a. You can, but the point is, if your computer walks away, someone can get into it. So yeah, you want to hang on to that key.
Sure.
If you notice that your key is gone, you go into the system that is protected by the key and say revoke the key, and then nothing can get in. So yeah, you need to keep eyes on the thing, but it's kind of like keeping eyes on, other things. But if your machine walks away, I can get the data off, and then I can take it to other machines as well. I can replicate and do bad things. So keep an eye on it. You can keep a physical eye on an object, right? Yes.
Cool. There was
Keep
just
it on
one.
your keychain.
I do actually have questions. This is amazing. Pardon me if I keep going. Stop me if you've heard this before. The SEP as the generation from it essentially holding on to that private key. How does that differ from other methods of, say, OpenSSL generate me a CSR?
It's essentially not different. Like I myself did a little tinkering with that. You can have an OpenSSL type piece of code generate a request that is backed by the SEP. But the point is that the private key, in that case, just like the YubiKey, is securely stored in a physical chip, and I cannot get it. I cannot say, give me the private key. It says, I don't know what that means. So that is the point. So YubiKey, SEP is really the same thing, only the SEP is on the, inside the computer. It's on the logic board. Yeah, well, free.
If it's copyable, it's insecure.
Right, exactly. Yeah, exactly.
I can copy your password out of your brain and copy your certificate
Yes.
out of your computer. You won't know I'm using it.
I can get your private key as it's stored in the implementation of generating the CSR when it's an OpenSSL type exchange.
If it's in the keychain, you can get to it.
Rock and roll.
That's the bottom line.
Thank
Who
you.
wants to speak?
One concern I'm seeing about this whole system, especially with the proxy, access proxy, is we're going back to a single point of failure again. Because if that goes down, then all applications beyond that point are locked out, whereas now we actually have like multiple paths to get to different services. And
That is true, but you can also look at it, first of all, obviously you want to, do your due diligence and do the proper, infrastructure load balancing that you would do anywhere else. So it's kind of like rolling your own crypto. You probably want to, do this in a somewhat, use as many things that are already out there to make redundancy and load balancing reliable. Sure, if you, let's say you stand all this up on Google and all of Google goes down, well, I guess we all go home, right? Because
Internets are off.
right, exactly. The tubes are closed. But the point being is that you can flip it around and you can say, well, if I don't have a single point of failure, but I say, then you also don't have a single point of attack. I can, if this is down, I can go there and attack you there and attack you there. You can concentrate your, sort of your, all your eyes and ears on that point of contact or failure, whatever you want to call it. So yeah, it's a balancing act. Any other questions? Going once, going twice. Made it. Throw in the catch box. Boom.
So say I sat through this and I found it really interesting. What would be a good next step? Just to maybe I want to stand it up at home, or get something just to play with in the cloud.
I really think what Google has right now, you can start playing with. Do like a trial. I forget exactly at what level you can. I think it's pretty easy to get into right now because they really want people to try this out. They're giving sort of the reference implementation. And again, we do a thing too, go talk to our people out there to talk about it, but they are doing the reference implementation to kind of get the word out that this is something you really want to look at because it is working out for them. And as they sort of give you more reference implementations, it becomes more interesting to actually start implementing. So I definitely would look at the papers that are there and just in general, there's a link directly to it's like / Google IP. So it's a well fleshed out bit of code at this point. Going once, going twice. Thank you for your time.